Although it moves windows on me every time I change them. All right. Good morning, everyone. So I have absolutely no slides whatsoever. So primarily just talking, and we're going to be starting to walk through some code in C# 10 and a preview of some of the things that are going to be coming along in C# 11. So I'm Bill Wagner. I work on the .NET content team, primarily focused on the managed languages, C#, VB, and F#. And our role is basically everything you see under docs.microsoft.com/.net or the learn content for .NET, and that is what my team produces. So as we start going through this, I really want to tell the story of what we're doing with the C# language. Because if you look at it as just a whole bundle of features, it can get kind of confusing, and we'll get some feedback, people saying, you know, we're just building a whole lot of features and there's no real clear direction. It's just adding features and doing all these things. And it's growing too fast. And I think by telling the story of what we're trying to accomplish, the way development is changing and has changed since C# 1.0, the rationale behind a lot of the features becomes a lot more clear, and the story becomes more clear, and understanding when you should leverage these new ideas becomes a lot more obvious. So let's start with some of the things that came in C# 10. And we're going to work through this with the idea of how programs grow over time. So we're going to start with a small program here that's got a record type, which is person, and it's doing a few different things with records that we started with C# 9. So I can just go ahead and start and run it in its current form, making use of the C# 9 features. There we go. And we just make a few person records. We print some things out, and we talk about the equality of records. So C# 9, we added records. The idea behind a record is that there's often times when you're building class types, and what you really want is equality to be these two objects have the same values, not these two objects are this, or these two variables refer to the same object. We want that value-based equality. And that's what declaring a record gives you. We just say, all right, so I've got a record, it's got a first name and a last name, and therefore the equality is whether or not those two hold the same values. And this is how we deal with data quite often. We're going to be pulling in data, and we want things to be equal when they happen to have the same values. And now if you look at historically in C#, and this fit the way we designed programs when C# was first spec'd out and C# 1.0 is shiny and new, we would do a lot of upfront design work, make a lot of design decisions, and then we would go write some code. Well, as we've grown more agile over the last 20 years, we do a lot more experimenting, we do a lot more prototyping, and then slowly mold some code that already exists into the structure and the organization that we want. So a lot of the things that we're doing with types now involve what we call having a grow-up story for simple prototypes. Things like anonymous types, which you may have used with link queries and such since C# 3. As you find you need those more often, they can grow up to become records. Things like tuples now that have just a couple different variables in them, or 3 variables, they can grow up to become structures or classes or records if you need that kind of behavior. So we make it easier to change your mind a little bit later in the design process as to, should this be a struct? Should this be a class? Should it be a record? Should it be a tuple? You know, how important is this to our program's design and to the domain? Sometimes we're just throwing a little bit of data around between some methods. A tuple makes sense. Then we find we're throwing that piece of data around among a large number of methods. It's actually something we want to track with a name, then have it grow up into something with a name. So that's some of what we were doing in C#10. Okay, records are classes with some extra methods that the compiler writes in order to enforce value-based equality. Okay, well, that sounds like something, a kind of feature we might want to use with structs. So let's first do a couple things. We're going to add the fact that you can declare a record. Did that in the wrong order. Just say it's a record class. And that is the same as saying it's a record. The default record type is a class type. But I can be explicit and communicate to anyone who's reading any of the code that I'm working with later that this is a class. Okay, everything should work exactly the same. So now, well, what are we going to do? Now what I can do is in C#10, I can say, you know, this person type I'm going to be using in a lot of arrays or a lot of collections. I don't want to start fragmenting memory by, you know, making references to these things that are really only 2 pointers, and I'd like to be a little bit more efficient with memory. So I really want record to be a struct. So starting with C#10, you can say, I have this record type. I would prefer that its storage be inline when it's used. So I would like that to be a struct. And if you note, I don't get any red squiggles anywhere else in this code. Okay, by changing from a class to a record, at least in this small example, everything works the same. We're going to quickly be able to update and let things work and just make that design change from a reference type to an equivalent struct type. And life is good. So what that means, and things that we've now done with structs, is now these with expressions, which were introduced in C#9, you can now use with a record struct type. What that with expression does is it takes the first argument, that person, his name is Scott Hunter, and it says, I want to make a copy of it, but while making the copy, I also want to change one or more of the properties. So I made a copy and I changed the last name. Okay, I can do the same thing here where I go back to make an original person and I change the last name again. So I have 2 different objects, 2 different storage locations, but the same value. So once we make that change to a record, or for record to a record struct, we can see, let's make our fonts a little bit bigger here. And we'll get, once again, you can see the equals operator and the equals method return true on both of those. Okay, so we have with expressions now with record structs. But as we did this, we said, you know, once you start making these changes, this with expression idea of taking an object and making a copy of it with some modifications, why should that be limited to records? Why can't we use it with other types? So let's say up here on line 4, I just delete person. Okay. Now, if I look at var, this var here, it now says it's an anonymous type, right? I'm now creating an anonymous type that happens to have the same first and last name properties as my record. First name and last name are still right there. And my with expressions still work because of course they do. Why can't we just make with expressions work with anonymous types? Well, once we do that, let's go back and we'll make that the type we wanted, because our grow up story for an anonymous type is, let's go ahead and make it a record. Well, the same kind of thing, we want to make it easier to switch between different types. You know, different types of things that we can create as we're prototyping and as things grow. And maybe later you find, you know, I'm not sure this should be a record. Maybe person is going to be just a regular struct. Okay. Well, now we're going to find a few different things. Now, our withers still work because we do have with expressions with any struct type. So you should be able to add or remove that record designation, which kind of modifies and adds some extra methods into a type. And with expression should still work. The only thing that now doesn't work is, if you'll note, because we didn't create an operator equals, that equals operator, I now have red squiggles because we didn't define that. We let the compiler define it for us as we were using a record. So we said, go ahead, use the record type, let the compiler build it for me. As a regular struct, I would have to write my own operator, equals operator. Similarly, the compiler for records writes get hash codes and the not equals operator. So an important thing is, in terms of adding records here, is if you think about how a struct type would implement equality in our equals method here, it's going to use reflection to find every property and to compare the values of those properties. The compiler generated version for a record or a record struct now says, okay, we know what properties are defined in this record, and it will use those properties itself. So it will write a more efficient code version. All right, so let's just comment that out, because we're going to keep working with our struct. Well, now, again, on this path of trying to make it so that we can let you make later design decisions, moving from between class type, record modifiers for class or struct, and a struct. Previously, in all versions before in C#, a struct could not have certain initializations. For instance, if I were to write public person, have no parameters here, and that would be totally illegal before C# 10. In C# 10, it's legal. If you note now, I am getting some red squiggles because I haven't definitely assigned the two properties or the backing fields for first name and last name. So when I write my default constructor, I'm going to have to assign first name, and we'll give it the at least American equivalent of what we don't know, someone's name. It's John Doe. And now that I've declared what both of those are and assigned all of the fields, this is a valid default constructor. So now, starting in C# 10, when you declare struct types, you can declare a default initializer or a default constructor. That means a few interesting bits of changes. And now if I'm here and I declare a person as a new person, I can now make yet another person, and that's going to equal new person. That's going to call that new constructor. And if I now do my right line with yet another person, that's now going to print John Doe. And now if I say some person, my default person, if that now equals the default, oops, I type in correctly. Now that initialization, that's going to be assigned to a default value where both the first and last names are going to be null. And the reason for that is we still do that, structs are still inline storage. CLR is still going to initialize everything to 0. And if you call the default value for it or assign it to the default value for that struct type, it's still going to be all zeros. It won't run your constructor. It also won't run any field initializers, because default is just like if I were to make an array of person, every single reference in that is still going to be null, or every single property is still going to be whatever 0 is for that default value for that struct. And again, this has to do with how you intend to use the types. Do you have a valid default initialization? Can you make that default constructor? And can it do something reasonable? Well, if we can have a default constructor, we probably ought to be able to do something like say, well, I may as well just use a field initializer here instead. I should be able to just say, that's equals John and equals Doe. And then I can remove those, because I'm just using the field initializer, and then any other constructors I add, those field initializers still get called. Now, remember I had made that comment about how if you assign a struct to the default value, your constructors don't run. It's default, it's all zeros. Same thing is true with field initializers. And to make that really clear when you're writing code, if I remove this default constructor, I now get an error on struct. I have the red squiggles here that says, okay, a struct that has field initializers must include at least one explicitly declared constructor. Because if I don't write any constructors at all, then the compiler doesn't create a default constructor, unlike a class. And therefore, there's no place to put the field initialization. So you have to declare a constructor. If you want it to be blank, you can just declare a blank empty-bodied constructor. That change is new, and it's a breaking change in the first preview for C# 11 that comes with .NET 6 SDK 60200 or Visual Studio 17.1. In that window between last November and this March, the compiler tried to create a default constructor, and then it ended up not working well because there were too many times with records, positional records, where it just couldn't define it correctly. All right, so that's a lot of what we will do with records and working with records and struct. And again, the big summary on this is we want to make it easier as your code base grows and as you prototype new features and as you learn how your code base is going to grow and how you're going to use different types. We want to make it easier for you to make decisions a little later and not have to pay for making those decisions and changing your mind. So when you're first quickly writing code, you can go, okay, I'm just passing around. I need to return 2 values from this method. I can make it a tuple. Super easy, lightweight, don't declare anything. I've just got 2 strings that come back from this method. And you find maybe I'm using that abstraction a lot. Okay, maybe make it a record or a record struct. When you get further along and you're even doing a little bit of performance testing, you can say, oh, maybe there's a lot of allocations here. Maybe I want to change it from a record class to a record struct. Maybe I'm finding there's a whole lot of behavior I want and this equality isn't right. You can revert from a record class just to a class, or from a record struct to a struct. And we're trying to make it so that there's less very serious changes that would ripple through your entire code base by making those changes. And further, we're trying to make it so that if you make those changes later on, the compiler tells you about things where your code is going to behave differently because you've now made that change. And the end result is we want to make it easier to start experimenting, start prototyping, and then defer some design decisions until you get a little bit further along in the process and learn more about the domain, learn more about the problem that you're trying to solve. So any questions about records, record types, and the kinds of things we're doing with the type system in general? Kind of watching chat as well. Okay, not seeing anything there. So our next big bucket is C#, because of its heritage in C, C++, other curly brace languages, has a fair amount of ceremony to it. And I've avoided some of that here in this code using some of the C# 9 features like top level statements. So this particular program is top level statements, and we've declared this struct in this other file. I'll go ahead and make that back to being a record struct, and then I can re-enable this, and we'll just remove that because that's not going to help us a whole lot. Okay, so I've got this program now, and I've started and I've used top level statements, and those kinds of things are really nice. But then as my program grows, I want to organize it in more different ways. As soon as I started prototyping a little bit, I find, I really don't want all these different types in one file. So we'll sit here I'm going to say I want to move this type to person.cs. Awesome. And now let's go into our person.cs. That's all good. I want to now put this type inside a namespace because my program is growing a little bit more. I am going to move it to a namespace, and I'm going to give it a model namespace. Okay, now we've got that. Now you see how much ceremony we just added. I just added, everything gets indented by 4 lines. I've got this namespace up here. I've got these curly brackets. That's a little bit more ceremony than I'd really like. For 20 years, we've forced everyone on every namespace. Every class we declare is indented by 4 spaces, and we've just wasted all those characters. And in almost every case, most files contain 1 or more types that are all in the same namespace. So let's just make a file scope namespace. And the tooling is now improved here, where if I just type a semicolon after that model, if you notice, the Visual Studio just saw exactly what I was doing, and it said, okay, I don't need those curly braces anymore. And now I've got a file scope namespace. Namespace model is here, and everything in this file is going to be in that namespace. Perfect. I get myself a little bit more horizontal space. And now I can give myself a little bit more breathing room. And since that's most of the time what we do, it seems like a really good trade-off just to make our code a little bit simpler, a little bit easier to work with. So now let's look at some other things we can do. In almost every program we have, we're going to have a collection of namespaces that we use. And, whether it's a console app, an ASP.NET web app, WPF app, Xamarin Forms, .NET MAUI, whatever. There's probably anywhere between 5 and a dozen namespaces that you're going to use everywhere in your program. So now let us make that easier. So we declare all of these things all over the place. So now let's say, I really don't want to do that. I'm going to hold down the Alt key and just give myself a typing cursor on every single one of these lines. And I'm just going to say I want to make those a global using statement. So now what happens is in this project, because I've got a global using, those namespaces are going to be added. That using declaration is going to be added to the top of every single one of the files I work with. So in every file in this project, those namespaces are now added on the top of every single one of those files. Perfect. So now if I save this, if I slide over into my program, I can remove any of my unnecessary usings, and we get rid of all of them there. Go into person. You do the same thing here. Because they're declared globally. Nice. Perfect. All right. Now, the next thing that happens is which namespaces are most likely to be used everywhere in your program. Depends on the kind of program you're writing. So I can now edit the project file. And this is an SDK feature more than it is a C# feature, but I can go in and I can write implicit usings. And if I enable those, now the .NET SDK and MS Build is going to add a global usings based on the target framework, here being .NET 6, it's a console app or a class library, and it will add a set of global usings automatically. So if after doing this enable, and then I'm going to just do a build. And if we look at we should add our model here. Oops. If we look inside that usings.cs, you can see that a lot of these should now show up as redundant. because they've already been used in the regular implicit usings. Now, in your domain, you may have specific things you want, like this model's classes. You may say, you know, it's going to get used in every single one of my projects anyway. So why don't I just configure it globally? So if I add a new item group, and one of the things that I'm going to add in there is a using, and I'm going to say to include is going to equal my model class. And now that adds that using global using model, similar to what I could have written here. It was just add a global using model. So now I no longer need to, in my program, should I do my next build? Those red squiggles should go away because my model class is now used globally in this project. So that's just some of our second bucket of trying to remove some clutter from our code, trying to make it easier to work with some things that are very common in every project. Hopefully mean that you look at fewer bits of ceremony that are so obviously the same in every single file in your project that your mind just glosses over them and moves on to the actual code you're trying to read. And we're going to continue to do some things like that to make certain statements a little bit easier. As we get to our last part, I'm going to add, while I'm in here in the project, I'm also going to enable nullable reference types because of a couple of features I'm going to show as we get a little bit further along. Okay, so now let's look at some of the things that we're trying to make it nice for developers who don't necessarily think exactly like the compiler does. Since the dawn of time, Lambda expressions have not had a type. So you've had to express exactly what type everything is in any Lambda expression. So a Lambda expression effectively before C#9 does not have a type, but it is an expression that can be converted to one of many different types. That's why sometimes you might not need to say what the input is, or might not need to say exactly what type is returned. And then when you assign it to a specific delegate or expression type, then what happens is the compiler says, well, can I convert this Lambda expression into this delegate type? And if it can, then that's what happens. Well, that makes life kind of hard sometimes, and it means there's some features we could never use well with Lambdas. So let's start to change that. So now, starting with C#10, Lambdas have what we call a natural type. So if I look at this, which is a func of string of int, I can say, you know, I could, if I wanted to, I can declare var. And the reason I can declare var is since this must be a string, so the parameter type must be a string, and int.parse here is going to return an int. Well, then if I hover over this var, that delegate, you can see is system.func of string int. Okay. That's because the compiler can figure it out. There is exactly one type. Now, if there isn't enough information, well, then the compiler is going to produce an error. So if I remove this here, well, now the compiler says, I can't figure out what this is, as could be any number of different kinds here. So I would have to say what type I wanted it to be. So I could continue, slide back here, and I could say this is a func of string int. That's going to work. Or if I wanted to use the var, I need to then say what s is in order to have the right type. All right. Now, it's also legal, if the compiler can figure out what type it is, that I can, on the left side of this, I can do different kinds of objects. I can say I want to make this an object. Okay. Since the delegate type func of int string is convertible to an object, that's cool. I can also say it's a delegate. Once again, that works. I could say, oops, come back here. I could say it is an expression. There we go. If I add the appropriate namespace, then I can make it any of those types as long as it can be used correctly. All right, so could also say that it is a specific type of expression. I could make it a Lambda expression. Now, when can we do this and when sometimes can't we do this? If I look at the next line, 2 lines down, back into our cursor here. If I were to try to change this function to a var, well, now this is going to be hard. And that is because the compiler can't tell for sure. It could return 1, which is an integer, or it could return the string 2, which is a different type. So in order to change that, I'm going to, if I wanted to use var or use it someplace var was needed, I need to specify a return type. And I can say object. Now this Lambda expression must return an object, because that is the most reasonable type that it could return. Now, why did we add all these? Right now I'm playing with them in just some C# code to give a very simple set of examples, so it's very obvious what the compiler is doing. The reason we added these kinds of features is for libraries like ASP.NET. If you've written any of the newer ASP.NET web applications, you'll find in startup.cs, you're configuring your DI containers, you're possibly doing some route handling, you're configuring controllers to handle certain routes and so on. And many of those take Lambda expressions. So by adding these features into the compiler, you can just write the Lambda expression instead of declaring a variable that has a certain type, writing the Lambda expression there, and then passing that variable in. Because now the compiler is going to do that configuring for you. And then finally, there's a couple things we can do here where we've added it as well with method groups. So console.read has only one type. So I can make that a variable. There's only one accessible type. If I were to try to do the same thing with write and console.write, because there are many different overloads, I have to specify which one. So again, where the compiler can, it's going to figure out what kind of Lambda expressions you're using and what it is convertible to. And if there is one best one, the compiler will determine that natural type, and it can just be used. But you're not losing any of the things that you could do before with Lambda expressions and handlers, because you'll be able to put those in place anytime you wanted. Now let's get to one last thing in C#10. And this is a feature that you're going to make use of, but chances are you're not going to write. And this is, again, kind of getting into our third bucket. That first bucket, remember, was making it a little bit easier to switch between different type declarations so that you can defer some design decisions until later. Second bucket is really removing a lot of clutter from your code so that C# can be a nice prototyping language, as well as then provide a very smooth transition to larger full-scale programs. Now, our third bucket is some really fine-tuning performance things that in many ways, there's one customer, the .NET runtime team, that does some things to really make the .NET runtime go faster. So you may not use any of these features, especially the one I'm about to talk to. But the reason they're added to the language is now the runtime team can use them. And it's one of many reasons why ASP.NET 6.0 is much, much faster than previous versions and continues to get improvements every release. So this is something called an interpolated string handler. So let's suppose you have something like, you're going to do something with debug assert, or maybe not even debug, but something that's logging even in production. And you're using an interpolated string, and one of the holes that you're going to do is going to be something that maybe takes a long time or does a lot of things with memory. In this example, it's a contrived example that just stops, sleeps for a second and then returns something. In previous versions of the runtime, this code would always wait for a second, whether condition was true or not, and whether something actually happens and gets written out. You still pay that cost to create that string every single time. Now, in C#10, if we look at this call to debug assert and we look at the rollover, instead of that second argument, instead of being a string, so it is that interpolated string already processed, it is something called a debug assert interpolated string handler, and it's passed by reference. Good Lord, what does that mean? And as we get into that, so then where that goes is, now what happens is there's a special string handler for methods like this, including our logging methods, that then say, would I actually use the string I'm about to produce? So it will look at things like log level. If it was a logger, debug assert, it will look to see if this condition is true. If it's if the condition is true, then nothing's going to get printed, and it doesn't even bother to compute the interpolated string. If it's going to get used, well, then it's going to do that expensive calculation because you want that output, and then it'll display the output. This got put into the runtime and significantly speeded up anything involving logging with different logging levels, especially with ASP.NET. So you can do whatever you want with any logging, anything all the way up through all the stack traces and all of that, expensive calculations. And when you've set the log level so it's not going to be written out, you don't pay for any of those costs to compute those strings. You probably won't write an interpolated string handler, but if you can, we've got a tutorial on Docs that shows how to do it, and then we move on from there. Okay, there's a great question in chat, is how do we gather feedback from the community before adding new keywords and features? And what kind of discussions on GitHub, online surveys, where are they? We look at a number of different signals. There are some online surveys. There are suggestions that someone might make in the C#Lang repo on GitHub, which is github.com/.net/C#Lang. And if there's a feature you want, anyone can propose something. And then, that starts the discussion. As I said, with this last bucket, we do listen to the runtime team about things that they need to make something that they, that's one of their deliverables, whether it's the runtime team, ASP.NET team, other partners, external partners as well, say, we need something to solve this problem. Now, what's interesting and what can be tough to watch is if you propose a feature or propose something, and I've seen this happen even with features I've proposed, you may very well see something come out the design review process that solves the problem that you articulated, but isn't the feature you requested. And that's because we look at all of those different signals, whether it's, and there's a few other things we look at as well. Like if you think back to C#8, where we added nullable reference types, one of the things we looked at was public code repositories on GitHub. And one of the things that we could find was that null reference exceptions exceeded every other exception type by almost 2-to-1 ratio. Same thing with any telemetry we got of crashes on programs. Those would also, null reference exception was overwhelmingly the most common. So this was clearly something we wanted the compiler to help with. So we wanted to put something in to say the compiler can now find these things for you. And those came into place. So we look at all of those signals and then do a lot of discussions over how does it fit into C#? And is there a solution to this that fits into C# idiomatically without making it, this just, I don't want to say just feels wrong, but this looks like we're taking the direction in a different, the language in a direction that doesn't make it seem still like C#. So we do put all those into place. And if you're really interested in any of the features, I would strongly recommend a couple different things. First, look at the discussions on C# Lang, and you'll see ideas that have been proposed, many of which may not get implemented. And I would almost guarantee that almost none of them will get implemented exactly as they're initially proposed. And the second thing is the language design team meets twice a week, Mondays and Wednesdays, roughly 5 o'clock, 6 o'clock GMT. And then the notes from that meeting usually get published within a day. So if you look at C# Lang under meetings, you will see both the agendas for what's going to be on the next LDM meetings, what's being discussed, and then the notes get published as a pull request, and you can comment on those as well. So we try to listen to anybody who's talking to us. And with that, I want to talk about a couple of the features that are coming in C# 11. So first, I'm going to hit the controversial one immediately. And this, again, is one in that bucket for the runtime team specifically requested it because of the library they're building. So we've got nullable reference types. So we can say things are definitely, they should not be null. And if I look at this build string method right here, it takes an object array. And because I've turned on nullable reference types, this should not be null. But if I'm building a library that's going to be consumed by, thousands, hundreds of thousands or millions of people, I know somebody is probably going to not have turned on nullable reference types, or may have a bug in their code and pass something anyway. So if I was a library developer, I would still probably do something like if args, I'll say is null, and then throw new argument null exception name of args. And if I'm building a large library, I'm going to have just a whole lot of stuff like that, especially with methods that may take 4, 5, 7 parameters and so on. And this is just going to start to drive me nuts. So right now, the preview feature is I can put 2 exclamation points after any argument. And you can try this yourself today if you want, but you're going to have to upgrade it to language version preview. And then if you put 2 exclamation points after any parameter declaration, then the compiler will add the code I just wrote and deleted. It will just test to see if that argument is null, and if so, it will throw the null reference exception. And basically, it would just look like this part right here. And right now, Visual Studio only turns it on for debug, which is a bit odd, but we would be able to put it in place for, you would put it just anywhere else in your code. Now, this one has generated a lot of discussion, and right now it is preview. The syntax for this might change. Good things about it is that people have told us as well is it makes it easier to add null parameter checking. So we're probably more likely to do it, which is good. The concern people have with the syntax is it might be easy to miss. And it's also yet another symbol rather than words or or some keyword that says, how do we know what this means? So there are possible alternative syntax that are being investigated. We may take that up. We're not sure yet, but we're continuing to listen on this one. So that's one of the features that's already available that's going to come out in C#11. Another one that has been more requested from the community, especially people that use either LINQ or use something to generate JSON text, is that starting in C#11, in interpolated strings, I could have something here where I can put any number of line breaks inside the holes inside an interpolated string, because everything from this open to the closed curly brace is just C#. So I could put something here like, it's datetime.now. If I were to have more complicated expressions, I could do something like datetime.now dot to UTC. And then I could even say .toString and give it some format if I wanted to, or just to long time string, whatever I wanted. And each of those could be on a different line because it's inside the hole. Not sure why. One too many of those. There we go. And so for if you are writing long things that produce interpolated strings, you can then just add however many carriage returns you want, as long as it's inside the curly braces for the holes of an interpolated string handler. Other things that are coming in C#11, one we're calling string literals, which is primarily for people who are trying to do something with JSON. So if you're trying to do something, let's say here in the string builder, if I wanted to put somebody's name here, okay, now that doesn't parse at all. That's just driving everybody nuts. So what I might do is I might say, okay, it's one of these verbatim strings, and then I have two quotes. Okay, that worked. But now if this was going to be like, say, a JSON packet, and I was using the element names and the element types, this starts to get pretty ugly pretty fast. So I don't think it's in the build that I'm using right now, but starting with C#11, if I put some arbitrary number of quotes to start things out, let's say 4, and then end it with 4. Anything inside it, I guess it is in this build, anything inside it will just be interpreted as the quote character. So for my JSON string, if I were to have some long string that I wanted for quotes, I could just say, I never need double quotes here, so I'm just going to use 3 or 4 or however many I want to start the string, and that same number ends it. And inside, any number of quotes, quote characters that isn't that number repeated is just going to be interpreted as a quote. So that's going to make it easier to write inline JSON or any other data file format inside your C# code. And that is pretty much where we are at with C#10 and 11. Hope this was fun. If there are any other questions, I will be happy to answer it. Otherwise, I will head over to the YouTube channel as well and answer some questions there and give space for Julie to start her talk. And thank you for inviting me once again.